Okay, here are some binomial expansion problems. And question number 1 here, we're being asked to determine the coefficient of a single term, and that term has to have an x to the 5 in it. So remember, if we have a binomial here to the power of 6, that means we have to choose from each of these binomials, all 6 of them, a magic number that's going to give us x to the power of 5. So before I consider what that second number is going to be, remember, we have to choose so many 5s and so many minus 2x's from these 6 binomials if we want to bypass the actual expansion of 6 of those binomials. And if we have an x to the power of 5, the only way that can happen if we choose 5 of those minus 2x's from the 6 binomials. So that means 6 choose 5 is our combination here, and of course we only need a single 5. Remember that first term, because remember the powers of course have to add to 6. So there we are. Now 6 choose 5 is just the number 6 whenever there's a difference of 1 there, and if you're not sure of that, I guess you could resort, since this is a non-calc, you could resort to this formula, which is a little bit overkill, but if you don't know what the answer is, I guess it's something that you would have to entertain. So n choose r is n factorial over r factorial divided by n minus r factorial. And remember, the n factorial, n minus r factorial is simply the fundamental counting principle, and the extra r factorial is removing order here, because of course order is not relevant once we multiply those 5 minus 2x items together there. So 6 choose 5 is going to be 6 factorial, and the difference is 1, so that's 1 factorial, and then I need 5 factorial on the bottom, and then you can see that that's going to be 6 times 5 all the way down to 1, and the 5 factorial gets crossed off, divides into 5 factorial on the bottom, will divide into the 1 on the top and give you 1, and that 1 factorial of course is just the number 1. So the answer is 6. So of course if you knew that 6 choose 5 was 6, there's no need to show that work. So it's going to be our coefficient here is going to be 6 multiplied by 5. And then just make sure that you know what minus 2 to the power of 5 is. And watch your negative here. That's going to be a negative answer. Right? You can use your fingers, I guess, here. 2, 4, 8, 16, 32. So we're going to have to figure out what 32 times 6 times 5 is. 30. Which is just 32 times 3 with an extra 0 on it, so that will be 96 with a 0 on it. And there's our coefficient, and be aware of course that is a negative coefficient because we have an odd number of minus 2's here. Okay, and our next question, we're going to find the smallest integer n such that the coefficient of the term in x to the power of 12 is greater than 1 million. So that means this n is of course the power on our binomial that we would be dealing with in this expansion. So that means our combination has to start with this unknown n. So it's a little bit more abstract than the last question, but we know our combination has to be n choose something. And the one really concrete thing here is that we do know that we need 4 x cubes chosen out of these n binomials, and that of course will give me 12 x's. If you multiply those powers, or just quickly multiply x cubed by itself 4 times, you definitely will have 12 x's. And that's some good news, and things are starting to take shape here. So that means my 2's, we have to choose exactly n minus 4 of those 2's, so that I make sure that when I add these powers, of course we have dealt with all n binomials in this expansion, since these powers of course add to up to n. So that means I can put n minus 4 or 4 and either one of those two numbers inside my combination. I guess technically it should be n minus 4, but both of those combinations are exactly the same. So we have a kind of a nasty expression here. It's going to be n choose 4. And if you want, it's not really necessary, but if you want to switch this into your factorials, I don't think that's actually easier to input into your TI Inspire, but if you want to, you could say this is n factorial divided by the difference of those two numbers in the combination, n minus 4 factorial, and the second number factorial. And I guess that's not a waste, because at least now we can see that if I had have went with n choose n minus 4, the difference would be 4, and the n minus 4 goes to the bottom. And we can see that those two combinations are the same, and it's not really anything to worry about. But what is to worry about is to recognize that, of course, this all represents the coefficient that's on this x to the power of 12 term. And I don't really care about the x to the power of 12 anymore, because now I'm going to focus solely on this coefficient, and I'm going to try to make this bigger than 1,000,000. Of course, there's an infinite number of n's that will do this, but we're being asked to determine the smallest integer n. You remember, an integer means nice round number, no decimals or fractions or anything weird like that. So clearly a paper 2 question. So let's just maybe as a starting point, before we use any fancy features on our TI Inspire, let's just take a couple of wild guesses at an n and see if we can get that number close to or bigger than 1,000,000. Okay, so here we are in the TI Inspire, and you can use the menu button, select a combination, or type NCR on your number pad, whichever you feel is faster for you. But anyway, here it is under the probability menu, combination, and it's going to be n choose r. So I think my initial guess is going to be, how about n equals 10? Of course, that's just a wild guess. That's probably not even that close. But at least it's a starting point before we look at a fancier feature on our TI Inspire. So n choose r, that's going to be 10 choose 4 multiplied by 2 to the power of 10 minus 4, which remember is n minus 4 in our exponent, which will just be 6. And moment of truth, is that number bigger than 1,000,000? And of course, it's not even close. So we can continue to do this, and I think I'll just double my guess to show you that it doesn't take long. Actually, if I don't even double it, if I go to like 15 or 16 here, why don't we go with 16? All right, so that's 16 choose 4, and that's going to be 16 minus 4 now in this power. So this is probably an accident waiting to happen, but you can do it this way. You can see that, yeah, that number is huge. It's way past 1,000,000. So if this approach is a little bit too hit and miss for you, then don't worry. There's a nice fancy feature called a numerical solve. And if you hit your little book icon there, you can hit the letter N, and it looks like I'm already there. And you can scroll down until you see N solve. And NSolve simply is a numerical approximation for an equation. Of course, it'll give us an exact answer if there's no decimals involved. You just type in the equation, tell the Inspire what the variable is that you have in your equation. So in this case, I guess I could type in my fraction with factorials in it, but I think I'll just opt for the probability combination again. And here's where it's a little more abstract, but I will say n, choose 4, and let the calc figure out what n is. Don't think I need a multiplication in there, but it's definitely not going to hurt. And this is going to be n minus 4. And of course, don't just put that expression in like I'm sometimes tempted to do. You need to put an equation in here. So we want to make sure how to, I guess, make that number equal to 1,000,000. So 1, 2, 3, 4, 5, 6. And I'm not done until I tell the Inspire what the variable is, and the variable is n. So let's see what happens there. And it tells us, hey, you need a power that's 13.975 or 0.98. Now, of course, we can only use integers, which means 13 is going to be not quite big enough, and 14 is going to be the number that we want here. So our initial guesses help us understand, I guess, what NSolve is saying, so that wasn't a waste of time. I noticed that 16 was way too big, which is reinforced here by our NSolve, which is telling us that 14 is actually the number that we want. So just go back up and grab this one again and say, how about just to show you that if we go 13 as our final answer, it's not going to be over 1,000,000. So 13 choose 4, and our power would be 13 minus 4, which of course is 9, and this should be less than 1,000,000, and it is considerably. But if I bump that up to 14 as my n value, and of course that will be 14 minus 4 on my 2's power, which is 10, and that's the first n value that's going to put this coefficient up over 1,000,000. So the correct answer here is n equals 14. Okay, our last problem. It says in the expansion of 2x minus 1 to the power of 9, the coefficient of the term in x to the power 5 is negative 496,128, where n is a positive integer, and we're being asked to find n. Now, I do have some kind of a font issue going on here. There should be an epsilon in here, of course. Let's see if I can squeeze one in here. That's not bad. Of course, that should say n belongs to the set of positive integers. Remember, capital Z, of course, is the symbol for integers in mathematics. So similar to the last question, we don't know the n on our binomial, but that still gives us a place to start here. We do know that we have to focus on x to the power of 5. So we're still going to start with a combination that's n choose something. Make my brush a little thicker here. There we go. And choose something, and I know that I need exactly 5 of these two x's. It's actually coming full circle a little bit. It's similar to the very first question in this video. And now I have a minus 1 that's going to have to, of course, be raised to the power of n minus 5. So my two powers here will add to give me 9. So I can either use n minus 5 in my second part of my combination, but of course 5 is a little bit easier to write and there's not much space there. So I want to make sure that this number is exactly the same as negative 496,128, and of course that is the number that's attached to the x to the power 5 term. So if I play around with this a little bit, I still have my combination of n choose 5. Now, of course, make sure you know that if you take 2x and multiply by itself 5 times, you're going to get 2 to the power of 5, right? And then you're going to get 5 x's, which of course I'll put over to the side here. And, oh yeah, I'm missing that negative 1 here as well. So that minus 1 to the n minus 5. So this is actually the coefficient that we're looking for here, and that of course should be the same as the coefficient over on the other side, which is negative 496,128, of course. So similar to the last problem, we really don't need to worry about the x5s at all now. We worried about it by making sure that our 2x was to the power 5, so that means in our coefficient here we have to include 2 to the power 5. Now that negative 1 base here, that's really nasty, and I thought I should point this out in this video. If you try to use nsolve with this minus 1, you're going to get an error message, and that's because with any time you have a variable in your exponent, negative bases are kind of a no-no, and it's not too shocking that your technology is going to have some problems there. So you can try doing that, but I wouldn't recommend spending much time on negative bases with your nsolve, because you are going to get weird, difficult to hard to decipher error messages. So let's just realize that depending on what n is, if n is odd, right, let's just maybe take a concrete number like 9, then 9 minus 5 is even. This will just be a plus 1. If n is even, like the number 10, 10 minus 5 is odd, so this would be a negative 1. So it's just going to basically affect whether this is going to be a positive or a negative coefficient. So you can kind of just forget it for the time being and focus. Oh, I didn't mean to erase that. Strike that off just gently. Don't worry about it right now and just try to focus on, which means don't worry about this negative right now as well. Just ignore that negative and know that the only hope of you getting a negative coefficient, of course, depends on that last part of our expression there. So that means our nsolve, we can bypass those weird error messages if we just focus on n choose 5 multiplied by 2 to the power 5, which is just 32. And we want to see if we can figure out what value of n is going to give us 496,128. Now keep in mind, when we do figure out our n, we should just make sure that this is going to produce an odd number up in this power here, which means n should be even in our final answer, and that will give us a negative along in this left-hand expression, which of course would be good news because that'll give us the correct negative coefficient. So let's go ahead now and jump back to our TI Inspire and see if we can do a quick nsolve on this expression. Okay, so here we are back in our TI Inspire using our nsolve command again, and we'll go and choose R. We know we need some kind of a combination that's going to be in the form of n choose 5, and that has to be multiplied by 32. Or just lazily 2 to the power 5. And we want to make sure this is equal to 496, 128. And don't forget to tell Inspire what your variable is. I'm really speaking to myself there, I think, mainly. And that tells us that, I guess NSolve tells us that our answer here is n equals 20. So if you go back and input that into your original expression with the -1, of course we will have 20 minus 5 on that as a power on that -1, which of course is 15, which is odd, which is good news. That means our coefficient is correct. It will be -496,128. So again, our final answer is n equals 20.